Hello and welcome to this video on how to do some analysis or interpretation of a full factorial single replicate experimental design. The goal in doing a full factorial single replicate design is to determine which of several factors are important in affecting a variable of interest and to come up with a model of how they affect that variable of interest. So here we have a regression model of the type that would be generated in this analysis. x1 is the variable that corresponds to a factor, and x1 can take values of -1 or 1. Similarly, x2 corresponds to another factor, 3 and 4, and so on. Doing the analysis gives us values for beta 1, beta 2, beta 3, beta 4, and also these interaction terms, beta 1, 2, beta 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. We don't have higher order interaction terms because we're assuming that the third order and fourth order interaction terms are negligible, and we use them to get an estimate of the random variation on our response variable, on our y. Doing the analysis of the experiment tells us which factors are significant, in the sense that it tells us which of these coefficients are significantly different than 0. A coefficient close to 0 means that the corresponding factor is not significant for the model. So for example, if we did an analysis and discovered that factors b and d and their interaction bd were significant, then in the model we could eliminate terms that do not include b or d. So this term, which corresponds to factor a typically, could be eliminated. This term, which corresponds to factor c, could be eliminated. And all of the interaction terms, except for the one that corresponds to BD, could be eliminated. So again, this is actually one of the fundamental reasons we do the experimental analysis, to determine which factors are significant and have to be considered in our model that relates the response variable we're looking at to the factors. Eliminating these factors gives the following linear model. Now, because in our model we've thrown away information, that is, we've thrown away the coefficients beta 1, beta 3, and all of the interaction coefficients except beta 2, 4, there may be a question of whether or not our model is still valid. We can check this by computing the model residuals. As you'll recall, a residual is a response value minus the value predicted by the model for given values of our factor variables. If I have 4 factors, that would correspond to 16 different combinations of factor variables, which would give me 16 different response values, and for which I could compute the predicted values, and I would look then at these residuals. So I'll set up the experimental design in JMP. I am not an expert with JMP, so I think that setting things up the way I will makes lots of sense. At least it does what we need it to do, but there may be other ways that make a lot more sense if you understand JMP better than I do. The first thing to do is set up the experiment. Now we'll copy the experimental results into our experiment table. Now we'll get the regression model with only the significant coefficients. So we go to Model. We'll delete those effects that are not significant. So we delete effect A and all the interaction effects associated with A. We delete the effect C and all the interaction effects associated with C. We're now left with effects B, D, and BD. This will give us a regression model with only the significant effects. And we now get this analysis. To find the residuals, we first need to save them. So we go down to Save Columns and Residuals. You can see that a column of residuals has magically appeared. Now we go to Analyze, Distribution, select our residuals, and now we go to normal quantile plot, and this plot here is the normal probability plot of our residuals. And you can see that these residuals are more or less on a straight line, although they actually vary pretty significantly from the straight line. So that means that there's probably some question about the validity of our regression model. At the risk of confusing you more than I already have, let me show you the residuals of the original model, that is, the model with all of the first and second order effects. So on the left we have the residuals from our regression model based on factor B and D and the interaction between B and D. On the right we have the residuals from our model that includes all the factors. And you can see that the residuals on the right fit closer to the straight line. This is what you would expect, even though we decided that two of the factors and their interactions were not significant. Including them in the model does give us a little more accuracy. When our model has only two significant factors, I can easily plug in values for these factors and determine which set of values maximizes my response variable. In other words, I could plug in -1 for x2 and -1 for x4, plug it in here, and compute y hat. Then I can plug in 1 for x2, -1 for x4, the same down here, and compute y hat again. And I have 4 different combinations I need to check to determine which factor values give me the best response. So that concludes this video on how to do some interpretation of the regression model generated by a full factorial single replicate experiment. Thanks for watching.